Hello and welcome to the So1 YouTube channel. My name is Ray, and in this video we're looking at the Raspberry Pi Robo hat and the PCA 8574. In this video we're looking at it as an input. So in the overhead camera view, I have removed the servo board output card so that it's easier to see what's going on down here. So from the last video, I had this wired between the VCC or 3.3 volt and the pin, output pin port 0, and I flashed the LED. In this video, I'm going from the ground on the other end of this header, and we're going to port 1. I've done an I2C detect because it has been powered down since the last time I've done this, and you can see without the hat on I'm only seeing the 20 hex, which is the PCF 8574, my two ADS 1115s. Down here is the PCA 9685. We've also got the MPR 121, and then we have at 68 the MPU 6050. Down here is at 70 is also the PCA 9685 for a broadcast address, so if you've got multiples of those on, you can talk to them. So let's get back to our Thonny program. So this is Python. We're going to use SMBus. I could have used SMBus too, but at the time when I was writing this, I was using SMBus. And we also need to import time so we can get our sleep. We set up our I2 address as 0x20. Our I2C bus is going to be an input, SMBus 1. So there are actually two I2C buses on the Raspberry Pi. One of them's used for the ID detect EEPROM and is not normally used, and it is highly advised you don't use it at all. It's reserved for the additions of things like Raspberry Pi hats. So we're always using bus 1, which is the general one for use by builders. We write out to the I2C bus to address 0x20 FF. Now there's only one register to write to on that device. Unlike an Arduino where you have to configure each pin as an input or an output with a pull-up resistor or not, or a pull-down resistor even. In the case of the PCF 8574, it does not have any of that fancy stuff. It will, let's have a look at the actual chip. This is the data sheet, so everything's controlled through this block diagram. But for a single I/O, what we have is from the shift data register, it will latch. Its output is either up or down, or high or low. When it's set to high, it will turn on this transistor and use this 100 microamp. So we're talking very, very small current, and send that to the pin. When it's set to low, so latched low, that gets turned off, and this gate here will take power from the pin and take it down to ground. And that can sink around about 20 milliamp without too much hassle, which is enough to drive an LED, and I took advantage of that previously in the last video. But in this video we're going to set it to high, and that way if we connect that pad down to ground, this junction here will be at 0, and it reads that back through essentially a buffer, which it then reads and sends back to, when we read the single input register, it sends it back to the Raspberry Pi. To do that, we're going to use this little bit of code. So we start out with it on high, so we write the output register to be high, and we're going to leave it at high all the way through this example, and we're only going to read the bytes. Now if there is no button pressed to ground, then it's going to return a high value. if we push the button, it's going to drag that pin low and it will return a low value. And that gives us some advantages. Like we could make it so that we have an LED on there, as we did with port 0, but if you drag that port down to the ground through a push button, we can sense that has been pressed on and actually set it to low and keep the LED on. So use it as a latch. And then after a period of time, we can release it, allowing the LED to turn off and the button to be sensed again. But in this case, for simplicity, I am just using this single button. I'm going to make sure that's pushed on, and we'll run this program. So it's showing that the button is currently released, which it is, and then if I push the button, it says the button is pressed. So very simple. Like I said, there's a lot more you can do with it. I do have some sample code to actually use a 4x4 keyboard matrix using all 8 pins. So it's a total of 16 buttons on 8 pins where we cycle through testing rows or columns, as the case may be, to see if any of the buttons are pushed. Well, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my patrons VIP Go Lucky, All Access Jeff Jerd, my Builder patrons El Morales 45, Andrew Cardone, Airgar69 and Stephus Paps in helping to support the channel. If you have any questions, leave a comment below, or a question in your comment below, or drop into the Discord and ask your question there. There is a link in the description, and we can answer any of the questions you have. And we will see you in the next video.